Okay, hello everyone. I think we're about to start. I hope you can hear me well and can see the slides. So my name is Anastasiia Kazakova. I work for JetBrains, and today I'm going to present a talk on C++ ecosystem and how it goes now, what is happening there, and which trends we see there. A little bit about myself. So I was an active C++ developer for quite many years, working in the embedded and networking areas. And so I was doing some interesting researches with Microsoft Research in the networking department. And I was working in the company called Yota here in Russia, which is the first company who started 4G LTE networks in Russia. And I was the part of these great activities. That was really cool and inspiring. And after that, I moved to JetBrains. And in JetBrains, I'm not like actively developing, especially in C++. I'm working as a product marketing manager for our C++ tools. I also do a C++ user group in St. Petersburg. So if you're anytime somewhere around when hopefully the world soon is back to normal and when we start the offline meetings, you're very welcome to join us. We really love guests, and we often have like talks in English, so that's totally fine for everyone to join. So I'll be talking today, and I really engage you to drop me questions during the talk. So I'm try to follow the Slack channel and the chat here in WebEx. So I will try to handle your questions on the way. That's totally fine. Let's make it some kind of like dialogue more than just a speech. That's what we are going to talk today about. So just a small agenda for you to know what to expect. And we'll start with this first part, which I called Powerful and Challenging C++. And we'll talk a little bit about why do I really consider the C++ the best language for quizzes. Let's start with the example with the mix of macro and some strange includes in some strange place. So what is happening here, if you take a look at this example, so I'm actually just define some macro and then try to define some enumeration using this macro. And actually this macro is used in this file included here, this xmacro.txt. And this xmacro.txt is not even like a proper C++ file. It's just a text file. And this include, which can be obviously like everywhere in your code. So here it's inside this enumeration definition. And so it actually, with the help of this macro, it defines some values for this enumeration. And the problem with macros is that they are these are the text substitutions which depends on the context. And at the time when you undefine the macro, you completely lose the information about what was going on there. So if this definition happens in some file and then in another file, I have some switch case operator going through the these generated values. So I found out myself in the situation when I don't know what are the whole set of values, where they're coming from. And it's good if I have a tool which can maybe suggest me some values I have here, like in completion or maybe some generating stuff. But if I don't, I do not know where these values are actually coming from. I have to try to find this definition, then try to find this txt file, try to match all these things together and get the output. And that's why macros in that sense are very challenging, because they're hiding some information. They're just text substitutions, so they are not just the part of the text. So I saw some very creepy code in my past experience in C++ where the file just starts with the macro and then it continues somewhere from the middle of the function. That's a very, very bad style, but it happens and these things are possible and you can do that. Another challenging thing is the overloads we have. Overloads themselves, they're like not really challenging. I mean, like there is a set of rules you have to follow, and you can try and do this exercise right now in your head. Try to guess what will be the output of these stream output operators. So what would be the output? So what you have actually to do, you have to consider all the overloads you have. There's just 5 you have here, and guess which one fits for which case. And it's like literally, it's not that complicated. It's just the set algorithm you have to process in your head. And I hope you played with it in your mind a little bit. And so I will share the correct answer here, which is 1251. So the first foo takes the first overload as a like person by reference. The second foo is just like the error value reference, so it goes to 2. And then this 3 is a very tricky one. It's the multi-character constant, and it's actually implementation defined. But as far as I know, it's like mostly 5 for in all cases I played with it. And the fourth is just the string, so it's just const char string here passed to the foo function. So actually, again, like 1251, but you can play with the example. When I said that the C++ is very good for quizzes, you can guess what you can do here. If you want a new quiz, just add a few overloads here or remove some overloads from here and get a new answer. And I can generate like tons of examples out of this very, very simple example here with just like a few overloads. So as I said, the function overloading is not that complicated, but to process it in your head is like not an easy task. We did this exercise actually yesterday at our workshop, and I guess I didn't get a correct answer from anyone in like maybe 5 minutes. And I didn't get a correct answer myself when I was trying to do that in my head for the first time. So it's totally fine. But like if you would like to generate a quiz again, you can add some overloads and it will make this example maybe even more complicated. So the goal of showing this example here is actually trying to explain the fact that with C++, you can generate some pretty interesting code, which can be tricky if you try to guess what's going on there. And this is some mind exercise you have to do when you try to understand the value of the code or just the stream output from your code. We also can overload operators, and this is even trickier because when you look at this output here in this very string, you can see that half of the stream output operators are the overloaded operators for my fraction class, like here, and that depends on the value here, but still. So these operators are overloaded. They do something different. Luckily, they actually print in the output to the output stream. But, you know, the typical joke about the C++, when you see a plus, you never know if it's a plus or a minus because it could be overloaded and it can do completely different thing. And the problem, the actual exercise you do in your mind is when you look at the code, you have to consider if the regular operator, for example, you see, is it actually what you expect from it, or it does something completely different. And that's a very unique thing for us in C++, and that makes reading the code much, much harder in comparison to other languages when there are no operators overload. This example I really like. It's very simple and in some sense kind of stupid because it does nothing interesting. But when you take a look at it, and the history of this example, I think I told it in several talks already, so some of you may know it. So this example is actually coming from our QA engineers. So the idea is that when we're testing our tools, we do some unit testing, some like performance testing, some smoke testing, and also we do some manual testing. And so our QA engineers are responsible as part of their task for this manual testing. So when we do support some new features in our IDE, and in that case, it was the variable templates. So they try to generate some tricky examples in C++ and play with them in the IDE. And the example actually broke the first implementation, so they created a ticket for the responsible developer. And obviously, the responsible developer asked a question like, what's the meaning of this code? Like, I see there is some wrong behavior or the IDE happening on the example, but why this code? Like, what it actually does? What's the meaning? And we were looking at this code, trying to understand what was the meaning of writing the code in that way. So we actually played with it a little bit. So we use another syntax for a variable template. We remove the template, then we remove the cast, and we end up in a very simple code, just returning 42. And that was it. I mean, like, this code did nothing apart of just returning 42. And this is the thing we have in C++ when we actually can do things in many ways. Like, we can do things in like 10 ways. So there are 10 ways of doing one thing, and it's not always good. And if you think about it more, there are lots of interesting talks we hear at C++ conferences about how we do things in several ways, like the initialization, this very famous talk from Nika about the initialization, where he lists like dozens of ways to initialize some simple things. And it could be funny, it could be educational, but if you think about it, so we literally have tons of ways to do one simple thing. And if you think about it more, you can understand that that's actually the problem, because when you have 10 ways of doing one thing, it could end up in some difficulties when you, for example, try to educate people, like how they should learn the language, which way of doing one thing they should like select as a default one, or should they learn all 10 and like literally from scratch get into details of which one is better, why the differences, and where to use what. And also it's difficult to agree on a common style, because these 10 ways, they all can be like completely legal. I mean, that they could be okay. It's okay to use all of them, but it's better when the whole code base is using one style of doing similar things. And you have to agree on this code style. And moreover, you have to follow this code style. So you need to have either the tools that will be catching, like some code analysis, maybe tools that will be catching you when you're doing some something in a wrong way, or some general agreement, or someone who is constantly reviewing the code for these style things. So it's not easy to maintain a common style. And I think we all agree that maintaining a common style is important if we want to make the whole team read the code easily, because otherwise it will be very difficult to understand what's going on there. And the next problem is coming out of this, that if you have some maybe old code base, which is probably maintained in some old style, but the style has changed. So what to do, how to maintain this code base? Do you have to refactor the whole code base and to change the style for these things done in one way to another way, or so what to do? So that's the interesting thing. So how you should deal with the code, how you should proceed when you're maintaining some like old code base in some old style. And I recently checked a very nice book published not so far ago from people from Google. It's called Software Engineering at Google, and there is a contribution of several people to this book. And there is this like Hirums law listed there, that with a sufficient number of uses of an API, it doesn't matter what you promise in the contract, all observable behaviors of your system will be dependent on by somebody. And if you try to project this to the thing I was talking before, you can probably guess that if there are 10 ways of doing one thing, probably all of them will be used. Maybe not in one small code base, but for the big team, for the big code base, the chances that all 10 will be used is quite high. And that makes the situation more complicated. So, like 10 ways of doing one thing is, don't get me wrong, it's not that bad. Language is really very powerful, but with the power comes the responsibility. So we have to understand how we deal with these things. like talking about these things in the language, I have to remember a few discussions in the community, like when the ranges entered the standard, the Eric Nibbler actually wrote a very nice blog post about how happy he is about the ranges entered the standard, and he was like using some example of the Pythagorean triples to demonstrate the power of the ranges. Maybe the example was not very successful, but it actually demonstrated the power of the ranges quite good. But there was a huge discussion on like about this blog post about if we really need this kind of a cognitive overhead in the language, and if the language goes into the direction when it becomes harder and harder to read. And there were several people replying like to this very famous thread started by Aris from Unity on this issue, and there were like a whole post done by Sean Parent in reply to that. So and you can read through this discussion, and you see that the people are actually really annoyed with the fact that the language is very powerful, but still very hard to deal with, hard to read, hard to understand, hard to like educate people about it. And when we were discussing similar things with the community, I still remember this thing from that was the times when we had some real booths at real conferences, and we had chances to meet people face by face. So at ACCU conference back in 2018, at our booth, someone just mentioned to me that the C++ developers must suffer, like we have a powerful language, so we have to suffer for that. But I was like, do we really have to, or can we somehow avoid it, maybe with the tools or with the language improving in that direction a little bit? Again, back to this thread regarding the Eric Nibbler's post on Rangers, like the Aris actually started this thread, and the thread is very long. I guess it's several hundreds of messages, and someone in this thread actually mentioned that we need some simple and debuggable code. And debuggable here, not in the sense that we can take the the regular debugger and debug it. No, in the way that we need a code that we can read easily, and the cognitive overhead is not that big. And there is one person in the community who actually tries to direct the whole language to this goal, is the Hirums, who is constantly voting for still more powerful but simpler C++, and he's voting for the language to be easy in that sense. And like before we move to the ecosystem research, one thing, about Hirums, actually, he once did a very interesting talk at CPPCon where he was discussing if the language is toolable enough, and if the language, so how the C++ community should get new features to the standard, if they should care about the toolability of these features, like if these features could be supported in a tool to be debuggable in this very sense. So you can read them, and there could be maybe tooling features that help to read and maintain the code base easier with these modern features. So now let's talk about some statistical facts. So here I'm going to talk about two ecosystem researches. So one is done by the C++ Foundation, and it's spread to the world from the ISO CPP website, and it's called C++ Foundation Light Survey. It runs regularly every year, somewhere around April. So this one for this year, for 2020, is already published. I mean, the results are already published. And for 2020, there are around 1,000 respondents for this survey. It's actually a huge research, but I will be talking here about the bias, and don't get me wrong, every research is somehow biased. It's biased by the people who are actually driving it because they have their goals, and that's totally fine. So, but it's important to understand this kind of a bias to be able to compare the results and to understand the differences. So the C++ Foundation survey is spread through the ISO CPP website, and the survey is in English only. So and if you take a look at the audience who is filling the survey, I will have some numbers later, so you can notice that mostly quite very professional developers are usually filling the survey. So the background of the people who are respondents to this survey is really incredible. So in JetBrains, we do the developer ecosystem survey for 5 years in a row already. We started in 2017. So it's 5 times already we did that. Usually we run it in the beginning of the year. So it's somewhere about like February, like January, February, March. And the goal for us, we run it not for C++ only, but for all the languages and technologies. And the goal for us is to understand the technological landscape. And that's like very understandable. We do tools. We need to understand how the ecosystems for the related technologies and languages look like. So we try to like limit lots of biases here. So we do translate the survey into like several languages. So it's 8 or 9. So it's like English, Chinese, German, French, Japanese, Korean, like Spanish, Portuguese, Turkish, like that. So, and the reason here is that before we started the developer ecosystem research, we found out that most of the developers are like 70% of the developers worldwide allocated in 18 countries. So our goal when we collect data for developer ecosystem research is to collect enough data for these very countries. So just to be sure that we covered like approximately 70% of the developers in the landscape. So, and we also know the distribution between the professional developers and students in these countries from different sources, and we try to weight our data per country to make sure that the data from the particular countries are not affected by the too many students, for example, filling this survey. And so we have quite the representative data for the country. So, and we run the survey until we get enough results. No, not in the particular time slot, but we promote it widely through various external channels. So we usually get the enough results in maybe like 2 months of running the survey. So this year we collected more than 19,000 replies, and 1,800, a little bit more from them are for C++. So this is the more or less a regular number we get yearly for C++, growing a little bit. There was a drop down after the European GDPR policy introduced, but still quite many replies we get for C++ part. And when I said that the audience is actually different, that's what I meant actually. So the audience for C++ Foundation Lite survey usually have more than 10 years of experience in development, and quite many are from 5 to 10. And so for 10 plus years, it's more than 66%. So the audience is very professional. I do believe that actually quite many people who are related to the C++ language committee are filling this survey and so on. So those developers who are in the language, in the ecosystem for quite a long time. For our developer ecosystem research, it's more balanced in terms of how many, what's the distribution per languages of, years of experience in development. So we also have those who are 10 plus years in the development, but it's about 18% only. So, and you can see that the distribution is more or less average. You even have quite many people with not less than 1 year experience. So for ecosystem research, when I look at the C++ data, definitely I take mostly the developer data, and it's nearly 81% are developers. So it's quite representative in that sense in terms of the people's role. Let's now look at some facts we got from this ecosystem research. In some places, I will be comparing to C++ Foundation Lite survey, so you can just check the difference. We actually do this every year. We do compare the results of the JetBrains developer ecosystem results with the C++ Foundation Lite survey. We even agreed with Hirums to align some questions so that we can have the similar questions in both surveys and can check the differences and can align the results in that sense. So this is distribution for C++ standards usage in 2020. Again, that's somewhere around February 2020. And you can see that, wow, nearly 12% are on C++20 already. That's really great. That's the year 2020, and we have quite many people in C++20 already. That's really great. So we also have quite many people on the C++17, the latest sign-up standard. 41% is the huge result. I will share with you in a minute the results for the previous year, and you'll see that it actually was growing for several years in a row, and it's good to see it 41%. And this 13% for C++ 9803 is very, very stable. I see it nearly every year, quite many people, nearly the same amount of them on this, all the standards, and they're not moving anywhere. And again, the majority of the developers here are on C++11 still. By the way, you might ask a very interesting question, like how many C++ developers we have in the world. In 2019, we estimated the number of C++ developers as 5.4 million. Out of it, 3.6 million of developers are professional C++ developers. So if you cut the hobbyist developers, if you cut the students, then you get 3.6 professional developers and 4.4 in total. If you compare these numbers to the Foundation Light survey, you see they have it's hard to compare actually, because they have a different grid. They have it in a different way. So they usually ask which particular features is allowed or partially allowed to use in the developers project. But you can see that even more, 22% here are allowed to use pretty much all from C++20, which is even more than we have. Again, for our survey, we have 12%, and here is 22. And here you can see how the things changed over the 3 years from 2017, 18, and 19. I didn't put 20 here because in 20 I changed the set of answers. I merged C++98 and 03, and I also introduced C++20, obviously. So I only compared here these 3 years, but you still can see that C++11 pretty much stable. C++17 is growing really, really fast. I would say it's really an impressive growth. So they also started with 12% in 2017. Again, that was the 17th year, so the year when the standard started, and then 18, and then 28, and now it's 41. These people are so these numbers kind of declining, but still very stable. So quite many people here. So these are declining, but altogether they again are quite stable here. So, and yeah, the majority are still on C++11. So this is the standard which gave us so many goodies that many people are probably happy with them, and they're not ready to move to any kind of risky and challenging standard, even if it's powerful enough, probably. This question is actually these rounds are from the question if you're ready, if you plan to move to a new standard in the next year. So, and you can see from which standard to which the people are planning to move in the next year. And quite many people, a little bit less than a half in average, are not planning to move anywhere. That's fine. But again, the next half of the people, the second half, are ready to move to a new standard. And it's obviously that if you're closer to C++20, for example, it's easier for you to move there. But it's great to see these 8% of the brave people who are ready to move to C++20 from 98/03 to the recent, to the latest standard, which is C++20. This is great. But let's think about what's the challenge of moving to a new standard? What you have to take into account when you move to a new standard? The C++ Foundation Light survey actually has a very interesting question. They ask, what are the major pain points you see in C++? So they try to understand how the people feel actually about the language, and they have quite many options there. And not that many people actually are selected the moving to a US standard as a major pain point. It's just 7%. It's much more for the others. But if you take a look at those which are trending, so these are the top 3 pain points for the C++ developers in 2020. So it's like managing the libraries, build times, and setting up the whole pipeline, including the CI/CD tests and so on and so forth. And these things are actually affected when you move to a new standard. So if the major pain point is managing the libraries in your application, if you move to a new standard, obviously you will be affected. Like your library maybe is not can't work with the new standard, or you have to find a new version out of like somewhere, and you have to build it. You have to like update this library. This could be risky. So while its own moving to a new standard is not considered by the like community as a major pain point, the things which are affected to it are actually really very, very tricky here. Yarn actually asked about if we've compared to the Meeting C++ survey. I think I did into some questions like unit testing and some others. Not all. I probably have to set up a workflow for Meeting C++ survey in the same way as Foundation. But for Foundation, it's easier because, as like to be honest, as the sponsors of the Foundation, we get the raw data, so we can compare the data easily, not just looking at the final PDF with the answers, but compare the like the results in every detail. So, but yeah, maybe I have to talk to Jens and discuss, maybe have some common questions and also compare with the Meeting C++ survey. But I guess from what I've seen, it's kind of similar. So the trends are still preserved. Let's move forward. So what are the risks of moving to a new standard? So they're kind of obvious, but let's sum them up. So like when you move to a new standard, you have to think about the libraries you're using or SDKs. It's like, for example, if you're in a game dev and you have the SDK for the consoles you are working for, like maybe doing the games for Xbox or PS4. So you can't move to a new standard if SDK is not yet there. So you still have first to get the SDK from the console provider and then console vendor, and then just update your code. So yeah, obviously you need to have a compiler which supports new features, but more or less nowadays the compilers are like good at that. So they're trying to catch up quite quickly. But apart from the compilers, other tools might still miss the support for new standards like the IDEs, the static analyzers, and like others, like maybe some unit testing frameworks, whatever. So you have to be sure that your tools are actually have this new standard supported. Things could compile, but you might have some linkage issues, or they even can compile and link, but they can work differently. And in that sense, you have to think before you move about if you have tests. So if you have some way to check that the behavior haven't changed for you. So, and obviously, like with the every newer standard, the developer expertise is very often lower than with the previous standard. Like in many companies for now, like expertise for C++11 is obviously much better than C++20. So when you're moving to a new standard, you have to consider if the whole team is actually comfortable with that move. So, and you have to educate people and to like bring the knowledge to them before doing the move. Otherwise, you'll just break the code base. And as I said, like if you are moving to a new standard, you'd better have some way to verify that you're not breaking things. And the easiest way is to do some tests, some like unit testing, for example. And I remember David Sankel discussing in his talk at CPCon in 2016, like how they are building the software capital system and what are the reasons people usually list why they're not writing unit tests. And that's very funny, I would say, very, very interesting reasons. And I obviously hear them quite often from many people, many developers, like, we're not doing the unit test because this is the UI code. Okay, but you can use like the emulators or simulators. We're not doing the unit test because it depends on a disk or a network. Like, okay, but you can like extract and test the business logic. like, or we're not doing the unit test because like we know the code is correct, or we need to ship this thing like right now or yesterday. These are not true reasons actually. Like the cost of the error after you ship the code will be much higher, so you probably understand that. And if you take a look at the unit tests, like how the people actually are using unit tests due to our developer ecosystem research, what we see here is that we have quite many people not doing any unit tests at all. I still hope they're doing some kind of other testing, maybe some fuzzing testing or regression testing or some other tests, and they maybe have some verification process or something. So this year, I especially added the option to say that I'm doing unit tests but not using the framework, so that I can get these people this 15% not inside this no test percent. So, and you see that the most popular framework is still Google Test. But the problem with the Google Test is that it's not like the standard, but quite many people are actually using it. It's very powerful. It's widespread. It's yeah, it's a good framework, but the problem is that that's a library you have to build, or you have to get the proper binary somewhere built with the proper flags. So of course you can say that like right now you can get, for example, the Google test via Conan or VC package, and that's actually good that we have these possibilities right now, because without them you have to like go somewhere, download the code, and build these Google tests with your code base. And that's why right now I think header-only frameworks are becoming even more popular than others. Like Catch, for example, it's now taking the exciting 14%. And I think the part of the success is that it works nicely with the like some of the recent standards, and it's the header only, so, and it's quite powerful, so it's actively catching up after the Google tests. So boost tests are a little bit declining, so you can use them, as you probably know, in a header-only mode, but that makes the compilation times quite long because, like, yeah, it's heavily templated, so you'd better not use it in that mode. So, but there is like, for example, this doc test, which is also header only, done by Viktor Kirillov, and it's growing, like it's 3% already. So, and it works with the recent C++ standards quite nicely. So, yeah, it can approach to the top as well. So let's move forward. So another way of checking the things are not broken by your move to a new standard is using some code analysis tools. And I was like, once I had a very interesting discussion at my user group. We were discussing some static analysis tools, and some people raised a point that they would like to run the static analysis on CI only, like somewhere during the weekend, and get the report on Monday. So just imagine the workflow. You do the code for the whole week, then you like maybe commit during the week, and on Friday it all goes somewhere, when on weekend it goes to the falls under some static analysis, and on Monday you get the report. I don't know about you, but I don't think I will be effectively fixing the issues on Monday after just the whole weekend. I think I will forget everything from the previous week. And so the effectiveness of the process won't be too high. So I personally do prefer to have these things in like running on the fly while I'm typing, or at least running them like constantly, maybe before the commit or right on my machine. So just to know what's going on there right now while I'm on this code. So, and we ask people in the developer ecosystem survey, like, what do you use for static analysis? And so 35% do not use anything, which is kind of sad. But 36% are actually using the tools built into their IDEs. And I would say that as a person working for the tools vendor, this is a huge responsibility, because I understand that if we don't bundle the tool, the developers won't be using it. which is sad, like, because the tools are useful, they could be very useful. So, but it's good to see that the people are relying on the like IDEs, for example, to get their code analysis, static analysis run on their code. And obviously, like, Clang family tools are very popular, nearly the standards like Clang Tidy, Clang Analyzer, and some others. Here I didn't put to the slide those which are less than 5%, like there is also PVS Studio and some others. And about the Clang Tidy, I have to mention that the Clang Tidy is actually very powerful, it's very good, but it has so many checks committed to the main repository from some companies which are very specific to these companies, that if you're working with the Clang Tidy and updating it constantly, you always have to think, if you need to, like, there are two major strategies, how to configure the Clang Tidy. You either, I call it asterisk and minus asterisk, like you either enable all, then remove some particular checks or groups, or just disable everything with minus asterisks and then add some particular checks or groups. In the first in the first way, you will just maybe get too much noise if some new checks are added and you were not expecting them when writing the config and you don't need them. And that constantly happens to the C++ developers. I see that. And if you follow the second strategy, you probably can miss some very useful check because it was added, but you don't know about it. You have everything enabled by default and just turn on some particular groups. There are some intermediate strategies for sure, so you can like play with the groups, enable this whole group or disable this whole group, but you still have to follow the changes when you update the Clang Tidy and probably update the config. So this is kind of a tricky process. If you, again, back to the list of the major pain points for C++ developers, you see that, like, as we see already, in the first place, there is this pain point with managing libraries. So, and we ask in the developer ecosystem survey, we started this question only in 2020. We ask about what are the ways of managing the dependencies in your project. And for C++, like, this is one of the major problems. So, like, we don't have anything standard de facto, and if you open any repository on GitHub, so most of the repositories in their README file on the top level, they will have not only the description of the project, but quite often the list of libraries you have to install to build it. And if the repository is good enough, it will list these libraries with like some particular links or maybe commands to install, and it will like provide instructions for all free platforms, because otherwise you don't know how to build the code. You take the repository, you take the library from GitHub, and you have no idea how to do that. And so without a standard package manager, it's kind of tricky. And you see that due to our survey, like, nearly half of the respondents are not using anything. So I guess they're doing that manually. So 23% using the system package manager, which is like, okay, like on Linux, I'm usually getting the things using the, like on Ubuntu, using the apt-get. NuGet, VC package, and Conan. And I would say that for the C++ Foundation, the Conan and VC package is much higher. It's like 14%. I have an assumption that might be connected to the fact that this audience of the C++ Foundation is like more professional. So when you, like a student, when you start with language, you don't care about the dependency manager, you don't think about it. You try to solve the problems manually, but like when you get year by years staying in the development, you understand probably need these things. So, but again, you can see that, yeah, quite many people are just putting the library source code as part of their build and try to manually deal with it. So that's how the world looks like for us. And what's the other side of this coin? Like, this problem is partially caused by the fact that we don't have a build system, the project model, the standard project model. So we have thousands of them, and we come into a situation of this like nice picture when we have like 14 or 15 or how many standards for project models we have in C++, quite many, I would say. There are like thousands of project models popular in the ecosystem. And Here I put both the C++ Foundation and developer ecosystem results on one plot just to show you some differences, because here we're not that aligned, and I wanted just to highlight that. But again, like the top three is the same for many years. It's CMake, Visual Studio Project, and Makefiles. CMake was not in the first place like 5 years ago, but it's overgrew the Visual Studio somewhere around 4 years ago, and it's constantly growing. Like it's if you check like Google Trends or something, you can find out that CMake is a very popular, and it's great. It's very powerful. The only problem with that is that it's not that easy. Like if you know it, if you can use it properly, if you can deal with the modern CMake style, that's very good. You get the very powerful cross-platform build system, which is actually a meta build system. You can generate like others out of it, like Visual Studio Project, Xcode, Makefiles, whatever. But I once ported the Makefiles project to CMake. It was a pain, and I was very happy after I did it. It really boosted productivity for the whole team, but it was a pain to port it actually there. So yeah, and if you check again the list of the major pain points in the C++ Foundation, I found this three there very funny. Like, all top project models are there in the pain point list. Like managing all of them is very tricky. So I will briefly go through the top usage area now, and to see how this data is actually aligned to the top usages area. So, and here we'll take the first three, which are the classical areas of C++ popularity, and they are still trending, like financial, banking, and trading stuff, embedded systems, and game development. There's also like machine learning, networking, artificial intelligence, and many other things. But we'll take a look at the first three. Like I'll go very briefly, but just trying to highlight the specifics of the area. So if you take the financial area, so you can understand like how the financial development looks like. It's like Java, C# for the front end, maybe some scripting languages, and obviously C++ for performance. And performance in the financial area means not the average value or the big throughput, but what is important there is a low latency. I mean, if you're in trending and if you did good 4 out of 5 times, but 1 out of 5 you lost, you're actually losing this game. Like you have to be winning 5 out of 5 to win in trading. So the performance is low latency here, and it's obviously that C++ is widely used there, and it's the main language for these tasks. So these people are often focused on very specific things like branch prediction or relocating the objects and using this kind of the pool of the pre-allocated objects, not to reallocate but better reuse the things. So and they always want to know what's going behind their code, so to what the code is actually compiling. And there's no surprise that one of the most popular tool in this area, like not in general in the ecosystem, actually came out of this area. And here I'm talking about the Compiler Explorer, obviously. Like Matt Godwell, the author of the Compiler Explorer, is working in trading for years, and the whole Compiler Explorer started as his like working tool to understand what's going on there, what the code is generated by the compiler, to understand how to improve the performance and how to improve the code in general. So the good thing is that the interesting thing is if you compare how the language standards are used in this group of people, you see that they are keen on kind of more modern standards. So C++ 20 is nearly 18%. 17 is like nearly the same. It's 40 against 41 in general, and less percents for C++ 14 and 11. So yeah, like they're a little bit more modern in terms of the C++ standard. And if you take a look at the unit tests, they obviously have some unit tests, and mostly they are using some famous frameworks to rely on. And you see the very big percent for the Boost test and quite high percent for Catch and Google test. So they do rely on some famous framework to do stuff, to check the stuff. Another area is the area which I originally came from. So this is the embedded. And embedded is very diverse. So there is like, you can play with pet projects in Arduino, or you can do some cool stuff with some like more or less standard boards like ST microelectronics board, or some more specific boards, or some very rare boards. So anyway, the whole market is actually captured by the vendors. I mean, like, you can't do anything if the vendor is not providing you the proper tools. So they all are relying on the SDKs, the starter kits, the custom compilers from those who do the hardware and the tools for it. So, and these people are they are appreciating the environments. I mean, those tools that can set the whole environment for you in which you can work, including all these tools, they are very, very popular. So, and for you take the testing, they are very focused on various certification tools, various standards compliance, especially all these like developers who are doing some self-driving cars nowadays. They have to pass some very specific certification to be able, like, obviously to run the self-driving cars on a like average road. So it's very strict. So it's not just about the unit testing, it's about the strict certification. So, but embedded world is still kind of behind the C++. You know, it's very much C specific. It's often C structs with pointers, some address arithmetics. And every time you get a board from a vendor, you get this huge specification with whole set of macros listing like some registers and how they behave and which values you have to put there. So it's kind of a little bit old school, but they still do that. Even though there are a lot of movement in the community to the direction of getting more C++, more modern C++ into embedded, and this is actually great. And this is how the standard distribution in the embedded area looks like. And you can notice that C++ 9803 is like more than average, and all the standards are more than average, but still like C++ 11 is kind of big here, and that's actually good. Let's go to the game castle. So I dived into this world some time ago, and I was really surprised how the language is utilized there. So if you take the segments of the AAA games, if you don't know, these are the most expensive games. So it's mostly done with the C++ custom engines, and also Unreal Engine. Like, in the world of games, there are actually two known engines who are dominating. It's like Unreal Engine and Unity. Unity is a C#, Unreal Engine is C++, but the rest of the AAA games market are mostly with custom C++ engines, which are often proprietary, so we don't know anything about them except for the fact that this is some C++ engine. And the C++, again, they are for performance, for the low latency. So the games area, they are mostly developing on Windows, and they do the rendering part in C, but the rest of the logic is in C++. And as I said, they're depending hardly on the SDKs coming from the console vendors. So if you're developing games, you're developing them probably for Windows desktops and consoles, the free major consoles at least. So you have to get the SDK to work with the consoles. So your games means nothing if or some of the major console. So you have to get the SDK, you have to work with it, and you have to like work with this library. The interesting thing there is that the whole area of game development is lacking the reflection mechanism in C++. This is probably the top voted feature for them in C++ they're waiting for. So they are using it for serialization and also for like adding some characteristics to the play character on the fly. And they all are emulating it in this or another way. I will show you briefly one example from Unreal Engine. So, and also they are very specific about the memory usage. Like, there is some very famous talk from Ubisoft from CBPCon, how they do the allocations in C++ because they are usually not happy with the like standards allocators, and they want the custom allocators to be the part of the typing for. So, and they're usually using arrays as the standard like memory structure. They are not using the heap. They are using the frame frame lifetime objects, which live for the time of the frame, and so on and so forth. So there are a few interesting talks from CPPCon if you're interested in how they do things. And there's this very interesting library from Electronic Arts, like the Estel done for game development. And when I talk about the reflection, that's what I mean for the Unreal Engine. So for example, in Unreal Engine, the reflection is done with macros. And these are these macros like uClass, uProperty, uFunction, which generates like get you some code for the reflection mechanism. And it's really complicated in the way that it's really macros. I mean, like you have to generate stuff to get the proper like code resolve in your tools, but that's how they work with the language. They are really waiting for the proper reflection in the language. And so, but they are very modern in terms of the standards they use. So they are mostly on the like C++ 17, more than half of them, and quite many with C++ 20, and less than average on the older standards. So you see that they're still moving quite fast, and I think they are actively participating in the like committee right now in this or other way, and like pushing some things they need. But obviously they mostly need the reflection. So to quickly wrap up here, I wanted to say that if you look at what's around us in 2020, so we actually have the C++ 20 standard. So, but we have lots of work to do after it. So like, for example, we have the models, but we don't have a modular standard library. We have coroutines, but we don't have coroutine supporting types in the standard library. So we still have things that were postponed for later standards like contracts, the reflection, the pattern matching, and there is the network and audio coming. So there's a very nice paper, which is the listing the overall plan for C++ 23. So you can see that there is a huge road ahead of us, and it's still lots of things coming to the standard. But I still hope that it won't make the language more complicated. Hopefully there will be people like Herb and others taking care of it. And if you ask the regular C++ developer, not in the C++ committee, but just the person doing the C++ development, like how do you feel about the language? And that's what I usually do at the conferences. I like asking people how they feel about the language. So you see some interesting trends, like C++ developers are they like constantly comparing the language to the others, like Rust, Go, D, and many others. You can quite often listen to the talks on how this or that language is compared to C++ on a C++ conference. That's very funny, actually, but also very interesting because we try to grab the best things out of this language. And the C++ developers often discuss this nice topic: what you would like to remove from the language if you could remove one thing. And so mostly because like the complexity often looks scary to many of them, especially those who are not that long in the language. But there is also a really nice overview of the 15 years of the language from Bjarne. And you can find it by the link and read it it's very, very long read. So be ready for a long read, but it's very interesting to see how Bjarne, at least as a creator of the language, sees what's going on there now. And that's mostly it. We just still have a couple of minutes for the questions, and I can proceed in the channel with the questions. And here are some references, and I will share the slides with the organizers so you can later grab them and check the references if you're interested in the researches or some talks I was mentioning here. And if you have any questions, I will be happy to answer. You can share them in Slack or in chat. Yeah, and thank you very much.